As you continue to self-host applications in your home lab, you'll find out that your home lab environment continues to grow in terms of the number of apps you're hosting and also the degree of complexity. So today, I wanted to discuss a little bit about what we can do to shore up that infrastructure a little bit more. And on the screen here, what you see is my NginX proxy manager, and I currently have 53 proxied applications. And then we have, of course, the port forwards for port 443 and port 80. So in April of 2024, I presented a tutorial entitled NginX Proxy Manager in NginX, which is a general guide to the easy configuration of NPM. And NPM is a Docker application, and so it can be deployed on a Docker server. It can be on a bare metal server running Docker, or it can be in a LXD container, an NginX container, or a virtual machine as a number of options. So today we want to look at some additional things that we're going to be doing in order to be able to provide higher availability. So in my last two videos entitled High Availability Pi-hole and Local DNS, and also add a new Pi-hole to the home lab, I showed how to provide a highly available local DNS in your home lab with multiple Pi-holes. These tutorials didn't require any interaction with NPM because the Pi-hole application runs completely locally. But back in February of 2023, I introduced the idea of using NginX Proxy Manager in conjunction with the Pi-hole to provide local network resolution for your subdomain named services, thus allowing for NPM to resolve those reverse proxy services even when your internet service provider connection is down. And if you self-host services with NPM, then if NPM is offline, none of your services would be reachable otherwise. In this video, I will show one possible solution to how you can run a backup NPM instance that can take over if your primary NPM instance goes down. And in August of 2024, I made a tutorial on SearXNG, privacy respecting self-hosted search. And since my self-hosted search engine is critical in my home lab, I'm going to show you how to create a backup SearXNG server that can take over in the event that your primary search server goes down, as just one example of how reverse proxied services can be provided with higher availability. And the way that we're going to do that is by creating a redundant NPM server and also a redundant search server, and then we're going to show how they can fail over if that is required in the event of an outage. My primary instance of NginX Proxy Manager, or NPM, is on my NginX server named VMS Mist. And so I want to create my backup instance of NPM on a different piece of hardware to provide the highest degree of availability. And so here I'm signed on to my application NginX server called VMS Rain. And in my case, I'm going to create an NginX container. You could go ahead and create a VM or use a bare metal machine for this. But I'm doing an NginX launch, images:/Ubuntu/2404. I'm naming this instance NPM backup. I'm using the default profile and also the bridge profile, which we learned about in NginX containers step by step. If you're new to NginX, you want to go ahead and watch my video, NginX Containers Step by Step, to learn how to build your own NginX server. And then we have boot.autostart equals to true, which means that this NPM backup instance will start anytime the NginX server VMS range starts. And then security.nesting equals to true, which means that since we have a Docker container, we need to be able to turn on nesting to nest the Docker application inside of NginX. With our container created, let's go ahead and move inside of the shell of this container with an NginX shell NPM backup. Anytime you create a new VM or a new container or even a new bare metal machine and install an OS, you always want to do an apt update & apt update upgrade -y to upgrade all the repositories and take all of the updates to any installed applications. Note here that I'm not using sudo because the NginX shell command signs in as root. Next, let's go ahead and install our dependencies, and in this particular case we're going to install curl, nano, net-tools, OpenSSH server, and rsync. And of course we get an error with OpenSSH server, and it says it depends upon the OpenSSH client. And this kind of thing happens occasionally, especially with live videos. So knowing that this type of thing occurs, I typically know what to do. In this case, I'm going to do an apt purge on OpenSSH client because that's where it says that the conflict is on the first line here, where it says OpenSSH client and it calls out the version number. So I'll do an apt purge on OpenSSH client, go ahead and say yes, and it does that. Now we'll try to install our dependencies once again and type Y to continue, and it will go ahead and install all of the requested dependencies, this time without any errors. With our dependencies installed, since NPM is a Docker application, let's install Docker with a curl command and run the script on the Docker website. Next, let's go ahead and add myself a user account with an add user Scott. I'll provide Scott a password, verify that password, and then I'll go ahead and do a usermod -a, capital G, sudo Scott, putting Scott in the sudo group, and the same thing, a usermod -a, capital G, docker Scott, to put Scott in the Docker group so that when I perform Docker commands, I do not need to provide sudo. Next, I want to find out what the address of my NPM backup container is. So if I do an if config, we notice that it's running at 172.16.1.94. Next, I go ahead and log into my Pi-hole, and I go down to local DNS, DNS records, and I'm going to go ahead and enter npm-backup, which will be the domain name on my local network for my NPM instance, and I type in 172.16.1.94 and then go ahead and add that to my list of DNS records. I'm running a Ubiquiti UDM Pro, and so I'm going to head over to my network control program, go down and find the address 172.16.1.94, and it finds NPM backup, which has been assigned a DHCP address. I head over to the gear and I say I want that to be a fixed address at 172.16.1.94. I click Apply Changes, and now it has a DHCP address reservation, and the address for that container will not change. Back on our NPM backup container, we want to go ahead and install an SSH key set with SSH-keygen, as you see here, and it will go ahead and generate a key pair. And in this particular case, I already have a key pair here, so I'm going to go ahead and say no because I created it earlier. At this point, I'm going to go ahead and log off of my NPM backup container with an exit command, and then I'm going to SSH over to my NPM production container. And now I'm going to install the rsync command with a sudo apt install rsync. Provide my sudo password and rsync will install. The next thing that I want to do is I'm going to go ahead and edit my host table because I just want to make sure that we have an entry for the NPM backup node, which I actually put in earlier. And I do realize that we put it in the DNS, but I'm going to do a sudo nano /etc/hosts. And in here on the NPM, I have a host table entry for 172.16.1.94 for NPM backup. Now that I know that that's the case, I'm going to go ahead and copy an ID over to that remote node with ssh-copy-id over to /home/scott ssd and the public key. So I go ahead and do that, and it goes ahead and says that it skipped all keys because they already exist on the remote system. And when I did a dry run, they were installed previously. On the production NPM container, let's do an ls. And of course, we have the folder NPM. I'm going to cd into NPM, which is all capitals if you followed my video on the installation of NginX Proxy Manager. Now if I do an ls, we have the config, data, and let's encrypt folders, and then we have the Docker compose file. Next, what we're going to go ahead and do is do a nano on replicate.sh. Replicate.sh is a script that we're going to create to be able to do the replication across to the NPM backup node. This script is going to run as a cron job or a batch job in Linux, and it has a few extra entries because a cron environment is really minimal. So one of the first things I'm doing is I'm creating an entry for the SSH agent to be able to store its information properly. And then what I'm doing is I'm executing an rsync command, and I have to provide the full path to rsync being /usr/bin. And rsync is going to synchronize an entire directory structure over to that location, which is on npm-backup that we just created using the key that we just created. So we'll go ahead and do a Control-O and enter, and a Control-X to exit the nano editor. Before we can execute a script in Linux, we need to grant it execute privilege. So we go ahead and do a chmod +X on replicate.sh. Next, we'll go ahead and execute the cron tab editor, which is the cron table editor. And when we hit enter, you may be prompted for which editor you want to use. I believe option number 1 is the option for the nano editor, which is really the simplest one that we've been using on the channel all along. And what my entry looks like is it looks like this, where I'm saying run this thing every 30 minutes and run rsync, and then go ahead and do the replication off to that NPM backup node, where it simply replicates everything in the home/scott/npm folder over to that remote instance for the NPM backup container. Just for the purposes of the video here, I'm going to go ahead and change this to every 3 minutes so we can get this to run in a hurry, and I'll come back and edit it later. We'll do a Control-O and enter to write the file out, and a Control-X to exit the nano editor. Now that about 3 minutes have passed, I'm going to go ahead and edit the cron table once again, and this time I'm going to change the 3 to a 30, meaning that it will perform a replication every 30 minutes because I really don't need to do it that often. And I'll go ahead and do a Control O and Enter to save the file out, and a Control X to exit the Nano editor. Now when I exit the NPM container and I SSH over to the NPM-backup container and do an ls, I now have an NPM folder. If I cd into that NPM folder and do an ls, I now have all of the data that was over on the NPM master container that we were originally running. All of the data has been replicated from the NPM production container over to the NPM backup container at this point. So I can do a docker compose up-d, and it hasn't yet pulled the Docker container, but it'll go ahead and pull the Docker container, but start it with the data that we have replicated over here locally. Just to make sure that the container is properly started, I'm going to do a docker ps, and here you can see that it has been up for just about 2 minutes. So I'm going to go ahead and go to my web browser and go to the address of 172.16.1.94, port 81. And it goes ahead and gives me a login prompt. And I'm going to go ahead and point my Bitwarden over to my instance of NPM and go ahead and fill in the password for it. And this is a new server, but it's a replication of the old server. And I'll go ahead and click sign in. And we got to sign in, and there are all 53 proxy hosts. At this point, if I make a modification to the main production version of NPM, that will be replicated over here to this backup NPM instance every 30 minutes. So let's go back down to the command prompt for the next steps. We're going to log off of NPM backup, and we're going to go ahead and log back into the production version of NPM. If you watch my previous 2 videos where we learned how to use Virtual Router Redundancy Protocol, or VRRP, to configure Pi holes that failed over, now we're going to go ahead and install the version here of Keep-Alive-D, which implements the VRRP protocol on the NPM server first of all. Let's edit the VRRP configuration file with the sudo nano /etc /keepalive-d/keepalive-d.conf. And our VRRP configuration here for our NPM production node is going to be specified as a master. Again, its interface, its Ethernet interface is ETH0. I've changed the virtual router ID because the virtual router ID for the Pi holes was 7. We had to use a different number for a different virtual network, and so we're making the virtual router ID 6 for our NPM configuration. Since this is a master node, the priority is set at 255. The advertising interval is once per second. We've set up a password, and it's 54321. You can have a more secure password on your end. And I selected an address inside of my LAN that I know is unused, and so I use 172.16.0.15. You're going to want to pick a virtual address that is outside of your DHCP scope, perhaps something like 192.168.1.5, and your DHCP scope probably starts at a number higher than that, but just verify that to make sure. So I do a Control O and Enter to write the file out, and a Control X to exit the nano editor. And then we can go ahead and look at the status of the Keep Alive D service by doing a sudo system status keep alive D, and it says condition unmet. It's not up and running properly yet, and that's because we need to do a sudo system ctl restart on keep alive D so we can read the new configuration file. Now if we look at the status, the service is active and running. Now let's go ahead and exit out of the NPM node, and let's go sign on to, well, let's see, we're not quite exited out of the NPM node. And now we're going to go ahead and connect back over to npm-backup. And we're going to do a similar thing here on npm-backup. That is that we're going to install the Keep Alive D daemon for VRRP with the sudo apt install keep alive D. And then we'll go ahead and tell it yes to install. And as soon as it installs, we'll go ahead and configure its configuration file. So again, we'll do a sudo nano /etc/ keep alive D /keep alive D.conf. And then once we get in there, we're going to be editing a keep alive D configuration file. And this time, this is going to be a backup node. So we have state as backup, interface is ETH0, again, router ID is 6, priority is 1 down at 254, advertising interval is 1, again, the virtual address is the same, as is the password. So I'll go ahead and do a Control O and Enter to write the file out, and a Control X to exit the nano editor. And just like before, if we go ahead and look at the status of the service, it is not up and running correctly. So we want to go ahead and do a restart since we created a new configuration file. In order for that file to take effect, we have to do a sudo system ctl restart on keep alive D. Now if we look at the status, you can see that it is up and running. In order to make all of this take effect, I've got to head over to my UDM Pro and go to Settings and then Security, and then I have to go look at my NginX Proxy Manager port 443, and instead of pointing to the address of 172.16.1.215, I want to instead point to the VRRP address of 172.16.0.15 and go ahead and save that. And then I want to go to NginX port 80, and likewise I want to change that production NPM server to be the virtual address of 172.16.0.15 here as well, and apply changes for it. So now we can see that we're pointing to the virtual address and not the address of either NPM or NPM backup. Now, headed back over to the Pi hole here, I'm going to do a search for Scotti-BYTE.com, and this is for my internal resolution for my addresses. And you can see here that Scotti-BYTE.com is pointing to 172.16.1.215, and I want to go ahead and delete that. And of course, I get some errors in the process of all of that. And then I'm going to go up here and define a new entry. Let's see, the domain is going to be Scotti-BYTE.com. And now the IP address for it, likewise, is 172.16.0.15. And go ahead and do an add on it. And now we have the new address for it. So here I am over in my Lex console GUI. And if we look down here at device ETH0 for the NPM container, you'll see that it has the local address of 172.16.1.215, but it also has the virtual address of 172.16.0.15, which means it is the master and it's still up and running. So if I go over here and I do something like go to Rocket Chat, or let's just say chat.Scotti-BYTE.com, I should get a login prompt there, and sure enough I do. If I come over here and I stop my NPM container, we'll wait for it to be completely stopped in just a second, hopefully. And now that it's stopped, I'll go over here to refresh this screen, and sure enough, I still get a login prompt for Rocket Chat because the VRRP domain has been failed over. And in fact, if I go over here to Lex Console and I go up to servers and I go to VMS Rain and I click on containers and I go down here to my NPM backup, which should be on the previous screen, I believe, NPM backup, you can see here that ETH0 now has the address of 172.16 or .0.15, and that means that it has taken over the role currently. So now if I go back up to servers and I go back to VMS Mist and I click on containers and I go down here and I find my NPM container, which is on the next page, and it should be stopped, and it is. If we go ahead and start it, it will start back up, and when it starts back up and gets an address, it will reclaim the virtual address of 172.16.0.15, and it will be responding to NPM reverse proxy requests. And now that the original production container for NPM is back up and running, you can see that it does have the address of 172.16.0.15, which means it is now resolving request to NginX Proxy Manager for reverse proxies. If you remember my video for privacy respecting self-hosted search, it's where I self-hosted an instance of SearXNG and customized it. And so the reason that's significant here is because it's a fairly simple application, and I thought as long as we have our NPM failing over, and since search.Scotti-BYTE.com is going to use that NPM, if one of my servers goes down, namely VMS Mist, that's hosting that service, I'd like that service to be able to fail over as well. Well, since we already have NPM failing over, it's simple to go ahead and create another virtual network for our containerized instance of SearXNG. Since my SearXNG is a container instance, we're going to leverage a couple of commands that we can use in NginX, and plus learn a couple of new ones. So the first thing that we want to do is we want to do an NginX stop on VMS Mist SearXNG. And that's the existing production container for the search. And then we're going to use a new command that I've not mentioned before, and we're going to do an NginX CP rather than an NginX move. So an NginX copy from VMS Mist SearXNG over to the server VMS Rain :SearXNG -backup is the name of the new container, and then I'm using --mode equals relay, which is a command that was recommended by Stefan Grabler, who does the NginX container maintainer site. And so he said this is a particularly fast command when you transfer or copy an instance. And so it's copying a copy of this instance from my VMS Mist server to my VMS Rain server. and it has completed that copy. So now that it's done that, we can go ahead and start the VMS Mist version of SearXNG. One interesting thing about the incus copy command is that when the container was copied, it receives a new MAC address, and so therefore it will receive a new DHCP address on the new container. So then we can turn around and do an incus start on VMS rain SearXNG -backup, and it'll go ahead and start that instance as well. If we head up to our web browser now and we head over to our UDM Pro and look at the controller program and then search in the client list for SearXNG-backup, we notice it here running at 172.16.1.234. So I'm going to go down here and specify this as a fixed address and do an apply changes. At this point in time, that SearXNG DHCP address is now a DHCP address reservation for the MAC address of that container, meaning that it will not change. Let's head on over to Pi-hole and let's go ahead and plug the same address in over here, and let's type in SearXNG-backup, and let's go ahead and do an add, and now we have a DNS entry for SearXNG-backup. Let's go ahead and head back down to our terminal, and this time we're going to do an SSH over to SearXNG, which is our original incus container for the searches. And then let's go ahead and do a sudo apt install on keepalive-d for the virtual router redundancy protocol. Once that gets done installing, and it just did, we're going to go ahead and edit the configuration file for it, just like we did for NPM. Now that we're in the editing session for it, we're going to enter a configuration file which makes the SearXNG original container here that we're editing the master for this particular virtual address. Again, it's interface ETH0. This time we're making the virtual router ID 8 because we have to choose a different number than we have for both the Pi-holes and also for NPM. The priority is 255 because it's a master. Again, the advertising interval is 1 second. We have an authentication information set up. And then this time, we're going to use the virtual address 172.16.0.30, which is different than what we used for both NPM and Pi-hole. So let's do a Control-O and Enter to write the file out, and a Control-X to exit the nano editor. Finally, let's go ahead and do a sudo systemctl restart on keepalive-d. And now if we come back here and do a systemctl status on keepalive-d, you'll see that it is up and running. Let's exit the SearXNG container, and next we're going to go ahead and SSH over to SearXNG-backup. And it'll say, would you like to connect? And we'll say yes, go ahead and do that. And because we had the SSH keys entered previously that I did when I set up my original SearXNG container, it logged me right into it. So at this point, we want to go ahead and pretty much do the same thing. We're going to do a install for the keepalive-d service. Provide our password. We're going to go ahead and edit. I'll go ahead and finish installing here because I did not push the -y on the end of the command. And then I'll go ahead and edit the configuration file. This time, we're going to have the SearXNG, but this particular backup machine will be a backup node in our VRRP configuration. So this is pretty much the same, except that the state is backup. The interface is still ETH0 inside of the container. The virtual router ID is 8 because that's what it was for our SearXNG virtual network. The priority is 254, which is one lower than the priority for the master. And then the advertising interval is still 1. And again, the virtual address is 172.16.0.30. We'll do a Control-O and Enter to write the file out, a Control-X to exit the nano editor. And then we want to go ahead and restart the Keep Alive D service with the command sudo systemctl restart keep alive D. And just to check and see that it's up and running, sudo systemctl status keep alive D, and you can see the service is running. At this point, we can go ahead and log out of the SearXNG backup or stop jobs. We'll do another exit, and here we are back on my desktop machine. Now we're going to head back up to our web browser, but this time we're going to go into NginX Proxy Manager, and we're going to list our proxy host. And I'm going to go ahead and go down the page until I find search.scotti-BYTE.com, which is my SearXNG subdomain name. I'm going to go ahead and edit it, but rather than it being 172.16.1.83, which was the address for the primary production server for SearXNG, I'm going to enter 172.16.0.30, which is the virtual address which can point to both of the SearXNG containers. In order to test this out, I'll go ahead and open another web tab, and I'll type in search.scotti-BYTE.com, and there you can see that I have my search up and running. Next, I'm going to go ahead and go over to my Lex console. I'll go into VMS Mist, where the original copy of SearXNG is running. I'll go ahead and click on it, and here you can see that it has the virtual address currently of 172.16.0.30. I'm going to go ahead and stop that SearXNG container, and it is stopped now. I'll come back over here, and I'll go ahead and refresh the page, and it's still there. If you don't believe me, I'll just go ahead and search for Scotti-BYTE, and it should be able to do the search, and sure enough, it comes back. Likewise, I can go back here and start up the SearXNG master container once again, and the system will fail back from the backup container back to this master container once it sees that this one is online. But we have SearXNG running on the VMS Mist NginX server, whereas we have SearXNG-backup running on the VMS Rain NginX server. So here we're waiting for it to get its address, and sure enough, it gets back its address of 172.16.1.83, but it also has the virtual address of 172.16.0.30. And since SearXNG really doesn't have any dynamic or changing data associated with it, I'm not worried about having a replication process out there to keep it up to date like I did for NPM. So anytime there's an update to SearXNG, I would have to log into first the primary container and do a docker compose pull, followed by a docker compose up-d, and then I would log into the backup container and do the same. Anyway, this provides you an additional way to have a higher availability service running on your network. So in summary, we used rsync with a cron job to keep our NPM server records replicated to a backup NPM server. And we use VRRP to provide automatic failover to the backup NPM server. And we changed the router port forward for ports 443 and 80 not to point to an individual instance of NPM, but to point to the VRRP virtual address for NPM. And then we adjusted the A record for my domain name in Pi-hole to point to the VRRP address for NPM in the event that we were resolving the service locally because our internet connection may have gone down. And then we made a copy of the SearXNG server and established a VRRP address for it. And we finally changed the NPM entry for the SearXNG service to point to the VRRP address as well. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.